So I think when I was younger, I wanted to be an astronaut.
It's one small step for man, one giant leap for mankind.
And then as I've got older, I've realised that that's really scary, sitting on top of all the propellants. So I think now I'd rather send people up into space rather than be the one going up there.
LURA stands for Leeds University Rocketry Association. We are not like a traditional society.
You know, we get support from the university, but ultimately we are running the association.
LURA is an interdisciplinary team of creatives and engineers working to prepare the Mars generation.
We are the generation of students who are probably going to end up either going to Mars ourselves or being responsible for that or just watching it.
It sort of has the goal of launch big rockets, progress student rocketry in the UK, and really show what students can do.
The goal for LURA right now is to get to the Kármán Line.
The Kármán Line is an imaginary line.
It's recognised as the edge of the atmosphere.
Which is the line in space, which is around 100 kilometers. We want to hit that, and we think we can.
The atmosphere doesn't really just stop at some point, but someone drew a line in the sky and said, this is space now.
And doing things like that, I mean, if you've seen any of the larger rockets, the scale of these engines to the rockets is massive, so scaling it down is a big challenge.
And there's just something cool about saying you've sent something actually to space, and that is the internationally recognized definition of space.
The Kármán Line is an arbitrary line, but it does symbolize something about the technological achievement.
You know, it's a difficult process, and the way to do that is to break it up in lots of small problems, and that's what we're doing with these projects. These projects have got a smaller goal in mind, which they achieve, which will all add up together to eventually reach that main goal of reaching the Kármán Line.
The saying, it's not rocket science. In this case, it is. It is really challenging, and so it's an important task to be able to do something not because it's easy, but because it's hard.
And eventually, if and when that happens, you can say, "Oh, I helped get there. I helped the University of Leeds and students to actually get the rocket which they built to space," which would be an amazing feat.
Theo Udes was the founder of LURA. During lockdown, he found on YouTube American rocketry, and he decided that was something that he wanted to do. So he got together a small group of his friends, and they said, we're going to set out to do this. And initially started with some very small rockets called Zippies when they're really small, and they worked incredibly hard. And they worked their way up, and they flew Gryphon I in the Spaceport America Cup.
I'm Theo Udes, and I'm the founder of LURA. Yeah, I think when I started LURA, I had short-term goals of what we wanted to do that year. And then beyond that, I'm not sure I'd say I had a goal. I had a vision of what it could be. The whole idea behind it was no one is going to take us seriously if we build up slowly. No one is going to give us money or space or funding if we kind of just wait for that to happen. So the whole idea was to give ourselves a crazy task that we weren't sure if we were going to be able to complete, and build a rocket and compete at the world's biggest competition, catch attention, and then we'll kind of catch our tail and figure everything else out later. Longer term, I just had this vision that what the university and what the school at the time that I was there was lacking was a really passionate student-led group that was separate to the course, of students being able to design, build and deliver their own projects. And there were lots of things that came into that. And one of the key elements of that was really, really important to us at the time was that it needed to include students from all over the university. We needed to make sure that we weren't just a random group of engineers in a back room tinkering with rocket components.
That looks good.
Okay,
But we were delivering meaningful projects across the university, bringing students from the business school, from marketing, from media into the team to run all different elements of LURA as if it was a business. I mean, LURA in almost every single way, is a startup, is a business.
All the decision making that goes on within LURA, all the organisation from every aspect is done by students. So we have support from the university and we have funding from the university, but as long as we are sensible with what we use that funding for, we are able to do what we want with it and run the organisation how we like.
There was no requirement on what course you did or what your background was in that way. That was always really, really important, that the whole team was multidisciplinary.
It's not just about the engineering. Like, I study geography, and you wouldn't think that's to do with rocketry, but it's about the operations and what goes on behind the scenes. You know, we have a launch coming up in a few weeks, but you know, that wouldn't be possible without the operations team who, you know, find the Airbnb, sort out the transport, sort out the plan for the day, accommodation, food, like everything. None of that would be possible without the operations team.
And I think when you bring in people with all different backgrounds like that, all bringing their own vision for the team, their own ideas, the final product you end up with is much richer than if you just get a few passionate engineers. The only requirement was that you were passionate, that you cared, and that you sort of shared our values of what LURA could be.
Welcome back. Busy week, very, very busy. I know a lot of you are doing a lot this weekend, so we're going to have a lot to cover in this meeting, so bear with me. We might overrun slightly, but we'll go as fast as we can. First thing, you all know this a million times, LURA values. What are they?
There are 5 LURA values, and those are be brave,
Be honest.
Own the task.
Get done.
And people over rockets. And those values are just like exactly what I'm looking for and exactly how I work.
And what the most important one that came out of that first year that we really learned a lot about from running the team is people over rockets.
The final goal, the final outcome really is that when you leave LURA, when you graduate, it's the people that are made. The rocket is what brings the people together, but it's the people at the end of the day who really matter.
At the moment, we've got a couple of projects happening. On the rocketry side of things, we've got G2 or Gryphon II,
which is designed to break the UK student amateur altitude record.
This is really focusing on the rocketry side of things, trying to push rockets as far as possible, which we need to do in order to be able to get to the Kármán Line.
On the liquid rocketry side of things, we have a project called Zola. That's an electric feed system. So it pumps cryogenics that will be later integrated into a rocket engine. And then we're also building and designing a liquid rocket engine called Caesar, which we aim to test fire this summer at Race to Space 2025.
Currently we're continuing with the solid development. And that's really good for developing general expertise in a lot of rocketry systems. You get the recovery, the avionics, all that kind of thing. But ultimately, we'd like to do a space shot. To do a space shot, you really need liquid engines because they're more efficient.
So liquid rocket engines has been kind of a standard in the rocketing world for a long time now. I mean, since Saturn, Atlas, all of these rockets that the US launched.
Because you have so many more complex elements in a liquid rocket, the engineering challenges are much more interesting.
You are basically creating a semi-controlled explosion inside this chamber and then using pressure to push it out the other end.
In order to build a full liquid rocket, we need the engine and the feed system, so it's really getting that developed so that we can put them together eventually, and then we can do a full liquid rocket launch.
Liquid rockets are where it's going. And the way we wanted it to work is we wanted to run G2 alongside our liquid bipropellant engine and hopefully combine them in the future. I believe we can get there. It will take a while with sponsorships, with the university. Funding is going to be the main thing for that. So the launch MRC could not have gone better. It was textbook launch. We had everything prepared on time. The launch went smoothly and nothing went wrong. There were no structural failures. The rocket was fully recoverable and we got flight data from the whole launch. It was amazing. So that launch was only 3,000 feet. The aim was essentially just to get the vehicle working. Does it go up? Does it come down? Does it survive? Yes. This next one is a bit scary.
Now the next stage is kind of going a bit more looking at the structural side of things. So can the rocket sustain the loads and stuff like that when it goes supersonic?
We're going supersonic for the first time. LURA's ever done supersonic. That's the main test here, is speed. Can the structural capabilities hold? Is it going to be strong enough? So we're going a lot higher. We're going 20,000 feet this time. There are so many more complications that come along with it.
It's starting now, say hi.
Hi to the vlog. Yeah.
I'm alive.
Hi everyone. We are 17 minutes away from the launch site.
Yeah. We can see windmills spinning.
We can see windmills.
The sun's out.
Yeah.
The sky's blue.
It's a great weather. We're loving this.
Yeah, it's looking hopeful.
So success would be both rockets fly and land safely, unscathed. And then I think the other success, though, would be just really like the team just getting a good idea of how a launch day would work.
Just so important to get that feel for what it's like to launch.
There are loads of things that go wrong on launch day. Launch day is one of the most stressful times of this mission.
We have had a failed previous launch attempt, so we went up to this launch site, and we were unable to launch Gryphon II. That was quite tough, but the team did really well. Still had a great time while we were up there, but we just struggled with the weather, and it was too windy really. We are at Fellymore launch site near Glasgow, and we've just built the launch silo for Gryphon II, and we are now test fitting the aft tube.
Hello. Really hyped up for this launch. I'm hyped. Let's go.
Oh, that's much better. Nice day.
Hang on, wait, ready.
Something that's considered successful is the rocket goes up, it reaches the record, so it goes over the altitude we're expecting, and that's recorded by the flight computers on board, and then it is fully recoverable. So the rocket is not damaged, the parachutes are deployed, and it comes back down safely. I mean, yes, essentially the fundamentals are you put it in a launch silo and you press a big button, but there's so much to it.
First step is set up the launch silo called Sentinel. That's what we launched the rocket out of. Really, really important bit of kit.
We have to make sure the weather's correct, so it's looking at weather data, running Monte Carlo simulations, so predicting where the rocket could land.
You set up something we have called MARU, which is our ignition circuit, how we hook the rocket up to where we're sat to press the button for liftoff.
Health and safety, things that go wrong, so that the motor exploding at the wrong time, ignition not going off, parachutes deploying early.
Set up the ground station, you set up gazebos, tables, chairs. The rocket will be making its way over while we're doing all these things, mainly because the rocket will most likely be having last-minute checks done. And then even when it gets to site, you've got to assemble it, but we have to run the checks.
Making sure there's lots of pre-flight tests, predictions, simulations.
Put the rocket in the launch silo, get the all clear from the range safety officers, and you have liftoff.
Ground station ready? Ground station ready.
Okay, we are going in 5, 4, 3, 2, 1.
Supersonic. Still rising.
Still rising, still rising.
Apogee 6,144. We're getting telemetry. 2 kilometers.
LURA was actually one of the reasons I chose to come to Leeds. Everyone is so dedicated and everybody works so hard that you actually get stuff done. I don't know, it's cool to actually work on a project and see like an end design.
So this launch really is making sure that we can actually recover the rocket, and actually we've got a good methodology to actually recover it.
Regardless of what happens, we'll still be really proud of all the hard work that the team's put into, especially on the Gryphon II dart sustainer, which they have built from an idea to an actual rocket now. And really, you know, with people over rockets, the aim is the people that we bring and the team that we make.
Seeing something I've worked on so hard for years and years and years, testing it, having failures, fixing things, it feels like yours, and you don't get that sense of it worked until the launch day.
I hope it all goes well, and I hope the engineers are proud of what they do, regardless of the outcome, because they've worked really hard on it.
It's really important for the team to see a launch. So it's a relatively new team in LURA. We've had a lot of recruits this year. None of them have seen a rocket launch before. So it's really important for them to see a launch, for them to get that rocket fever and, you know, really get what it's all about.
Oh, there he is! I know, that was great. I've lost it now.
It's a rocket.
Where's the bun? I've lost it. Down to 700.
Essentially, for a rocket to be a success, it has to come down safely.
Approaching main.
This couple of seconds where we were thinking, right, the first parachutes to deploy, and then it felt like a year.
No main so far, no main.
Like, oh, will it actually unfurl correctly? You wait, and then you're like, okay, the drone, the main should start deploying now.
We haven't deployed.
You don't really want, let's say our parachutes fail, that thing's coming down, you know, you don't want to be anywhere near that when it lands.
I think we've lost it.
If we've miscalculated the descent velocities and it hits the floor and destroys, that's not successful to us.
Yes, we haven't had it for 30 seconds. We haven't had it for 30 seconds.
Anybody come in through radio?
William, how was that?
I'm proud of my rocketry team. I think we did a great job, and I'm really excited for more cool, really high launches to come.
Yay!
LURA has already, over the last 4 years, done so many amazing things in that time with the people that have been involved in it. I think LURA has already left a great legacy at the university. I think it's become a really integral part of the School of Mechanical Engineering.
It's very hard to go into the aerospace industry, and especially the rocketry and space industry, but also it is so cool. I mean, not often you can say you're launching a supersonic rocket.
Morgan, do you have the rocket? We have the rocket. Defend your order now. Yes.
All I ever hope for LURA, really, beyond all the technical stuff that I've loved seeing them do, but all I really hope is that it continues to inspire students to follow their dream in aerospace engineering, to bring passion and energy to the sector, to work in jobs that excite them, and if there aren't jobs that excite them, then create those jobs.
If I look back where I was when I joined to where I am now, it's like I'm way more comfortable where I am. But I just want to keep learning. I want to keep learning as much as I can.
When I think about LURA now, I think more about the people and the leadership lessons that I learned
and the mistakes that I made and have had to sort of confront and learn from since then, that's the most valuable thing for me, and there is no way to learn that other than firsthand. It's such a good opportunity being in LURA. Like, where do you ever get this chance for completely free, completely voluntarily, you can build a rocket to go supersonic? That's crazy. It's crazy. And I think I would be stupid to not do everything I can while I'm here.
I didn't think I'd join this and find it fun, but I actually do. You know, I've never really been so passionate about rockets and engineering, but hearing about what the engineers are doing and actually seeing it, it's so different from just hearing it. Like being in the workshop when things are being soldered together and made, and you know, it's just so exciting, and seeing the dynamics of how such an organisation works. Like again, it's not just the engineers, it's a team of so many different people, all very passionate, all very creative.
People that have been involved in LURA graduate with a much richer skill set than those who have just gone to the classes and haven't been involved with projects like that.
Well, I remember seeing G2 for the first time and I thought, uni students built that rocket. What? It's absolutely amazing piece of engineering. You know, the thought that's gone into it is absolutely incredible.
I think my experience at uni has been my degree, but has also been all the stuff I've done alongside my degree, which I think is more valuable than just a degree certificate.
It's fun and you're actually doing hands-on engineering instead of just sitting and learning.
What have you done that's sort of different, and what can you show for it? Like, what story can you tell?
My motivation comes from wanting to push the boundaries and wanting to drive innovation.
I've learned that, you know, anybody can do anything, and all you've got to do is put your mind to it.
No matter where you're going at university, and frankly, no matter where you're studying, you know, that you need to get out and create these opportunities and get involved with a team and build something.
It has to the rock motion, right? Or your hand motion, like a whipping somebody.
Okay.
If you just whip it, it just goes far.
Hang on, so she can't throw stuff, but then you're going to assume she can whip stuff?
Nah, no, you gotta whip it. You gotta actually whip it.
I'm shockingly bad at ball sports.
Are you joking?
No, I'm really bad.
Are you gonna give me the ick now?
That was quite bad.
Oh my god. I can't.
So that's on tape.
The Kármán Line, it certainly won't be while I'm in LURA, that's for sure.